One of the #1 complaints, questions, requests we get is about how to approach family, friends, or coworkers about these topics that you investigate every day that we are all so impassioned about, and how to introduce this community. In this video, we will show how our 5 core topics of application are doing. The points here are what you should share, and below the video in the description box you will have them for easy reference later. It'll include success in creating an earthquake forecasting model based on electricity, and we'll see how NASA is now hot on that trail, faster than I was prepared to see. Success in dark matter science predictions with a well-reasoned future forecast. Our tracking of the sun and cyclones comports with published work and inspired the National Middle School Science Championship project. Our external seismic forecasting observations were validated by a statistics professor and NASA scientist. And lastly, our climate change position appears to be where the current paradigm is heading to meet the stated changes upcoming in the next model. Now, before we actually get into all of those, our primary free resource is spaceweathernews.com, where you can become one of the top 1% most knowledgeable space weather individuals on Earth in about 1 hour, and where you can find real-time data and satellite feeds, news updates and videos, community information, and more. We have a number of free resources, including a total Sun and Earth update every day, 365 days a year since 2011. We aim to have that diligence and consistency reflected in our mindset, approach to information, and trajectory relative to the world of possibilities. Now, this is by no means a rule or official chart of anybody's. It is just something put together to demonstrate where the observer's community tends to fall, which we aim to show in this video. We want to explore the unknown using validated mainstream science to find the holes, cracks, and missing pieces, and also the shreds of truth in the myths upon which something sensational was once founded. What this has done is allowed us to narrow our focus to some core areas outside of these daily updates, and here is a deeper look at each. Let's begin with electric currents and earthquakes. We spent years reading papers and developing a list of pre-seismic signals that work and those that didn't. This is an outgoing long-wave radiation anomaly map, and it is one of the better things to focus on. It is sometimes called OLR, thermal or infrared radiation or emission, and accompanies atmospheric electron content and other electromagnetic anomalies among the list of things that we think work. Each indicates that electricity might be their genesis in the ground, and so we explored the possibilities of deep currents. This image, by the way, was made by ETH Zurich, and at the time, I had no clue what a role they would eventually play in this game. Remember that name in a few minutes. The ground is full of water, more than you can imagine, and the primary mantle constituent is olivine. Let's see how those would react to alleged underground currents in part of my presentation from Observing the Frontier in April of 2017.
This stuff is really cool. He started without any arc. That is a drop of water. This is not sound vibration. This is not cymatics. This is just electric current in dark mode. Before we saw it in lightning mode, discharge, arc mode, where you could see it, that whitish, purplish plasma. Here, he just didn't turn up the power enough to do it, because if you actually do get an arc discharge, all the vibration and cymatic patterns disappear. So we're going to zoom in a little bit on it here. When he turns on the current, all that is an electrode above. Technically, that would be the anode. The cathode would be below. But you should be able to see how the water is sort of rippling around and moving. It happened too quick there for you to see, but when there was a little lightning bolt, everything went calm for a moment. But there's more than just the shaking, because when we get to real power, and this is just water with some pyronine added for visual effect, water will be attracted to this current. Water will get pulled by the current. So you could see there, the current was just going into the crack, the low resistivity zone, like it's supposed to. But the water knew this was going on, and the water wanted to come be a part of it. Now watch this. This is how attractive current is to water. It is painting the fault lines of the rock with the pyronine. Now think about this at the scale of the Pacific Ocean, at the scale of enormous plates. But if you're going to be thinking about it at that scale, we might want to think about, well, okay, it cannot just be attracted, but look at how it's pushed out among the lightning bolts. Now, granted, we don't have literal lightning underground, although some folks at the USGS are actually starting to think we do. This is really cool. Watch what happens. So much for gravity. When we hit the current, that water starts pushing up on the sandstone. Now you start to think of this over the scale of a country, over thousands of miles. These tiny subtle effects of water pushing up or pushing down or side to side. This is olivine crystals right here, and they can shimmy a little bit on charging, but when Billy goes to discharge them, that's when we really see the action. They self-translocate relative to one another as they are discharging their electricity. We'll just watch a little bit more of this here because it is super cool. And so as you can see, he'll nudge some and they'll jostle, but what that is that's a grounding rod. He's grounding them. He is discharging all of the electricity that he fired in. Now, what I didn't show was he spent about 60 seconds to 2 minutes firing 70,000 volts into these crystals. So these things aren't just, you can't just grab a bunch of olivine and go do this on your table. We charge them up, just like they would if they were introduced to electric current down in the mantle, and extra pressure and extra temperature, things of that nature. This is really cool. So no current right now, and as we turn the current on, the olivine acts like a magnetic field and starts spinning the water around it. Do you see the particles in the water spinning? That's just the current hitting the olivine. So we have water in these subducted crusts. The number one mineral component of the mantle is olivine. And look at how they react to electricity. It's preposterous. Okay, so we have our water and olivine effects from the current. They appear to have the ability to translocate just based on their interaction with electric current. And of course, if you get the electric current down there, you will also have heat created when it interacts with the resistors. You'll have the magnetic fields created by those currents. Then, of course, you'll have electrolysis if it hits the water, splitting into hydrogen gas and oxygen gas, which is extraordinarily volatile. But we also have the electromagnetokinetic phenomenon. And I'll be darned if this isn't utterly absent from modern academia. 1953, Alexander Colin studies and reports the electromagnetokinetic phenomenon. Almost nobody in academia cites it ever, but it is used almost ubiquitously in the separation of melted metals, in biological applications like separating biological materials, DNA, and other things like that. When it is used in smelting and separating melted aluminum and things like that, it's called electromagnetophoresis. Or when they're talking about separating biological materials, they refer to it as electromagnetic buoyancy. But it is all the result of the electromagnetokinetic principle from 1953, and that is that even if the matter is neutral, it can be translocated by enough current, and the push is perpendicular to both the current and the magnetic field. And so that's what this looks like. If you've got current coming one way and the magnetic field wrapped around it, those pushes outward from the magnetic field, which are perpendicular to the magnetic field, but to do that, they have to be pointing out in every direction around it. And in doing so, they're also perpendicular to the current. This is why whenever Billy puts an arc discharge into the ground, it blows out a perfectly circular crater because it's going in, the magnetic field's going around it, and there's an equal push all around. And we've had a number of you guys in some of your own home laboratories recreate Billy's arc discharge craters, and you really cannot tell the difference between one of those and an alleged boloid impactor.
So it turns out that water and olivine and basically anything at all down there can be shook, resonated, or translocated by simple electric currents. Using these principles and a few from recent atmospheric global electric circuit science and space weather, we created a system of identifying the most likely electrically active fault zones, and although this can be constrained daily to only about 10% of global faults, 68% of the largest earthquakes since model inception have been in those exact areas, including some not considered to be the most active regions on Earth. This chart is accurate as of November 12, 2017. And as we have been continuing the daily grind of location identification, we looked up in the rearview mirror a few days ago and found that very same ETH Zurich alongside NASA, and I can see the whites of their eyes. They are seeking to identify electronic changes in the ground occurring prior to the occurrence of earthquakes, and the primary agent responsible would be electric currents in the ground. If this sounds familiar, let's go a bit further. They say what led them there and how they will try to track these is infrared emission, that OLR we saw earlier, and things like electron content in the atmosphere and electromagnetic anomalies, which occur due to space weather and major lightning storms. In no way did we discover any of these precursors. In fact, the energetic and atmospheric phenomena have been documented for centuries, but it was putting them together with new atmospheric circuit science and space weather understanding that led to a model that represents a small step towards practical earthquake forecasting. The bad news is that NASA and Zurich have a lot more funding than I do, and they have a ton of momentum, but then again, if they succeed, how is that really bad news? Moving on. Primary thing people in the community have agreed on for years is that dark matter searches are going to fail, and they are underappreciating electricity and energetic effects. Here is the vindication and death of the lambda cold dark matter paradigm in 4 minutes. 15 months after the Duke of CERN had to admit they cannot find what they were looking for. Then, a few weeks later, others stated they didn't need it in their models. A few weeks later, other models that didn't need dark matter or Einstein's relativity began passing their first tests. We're still in the fall of 2016 at that point. They looked elsewhere last winter and still couldn't find the dark matter. And on the same day, news was released explaining even more models that work without dark energy. They started adding cherries and sprinkles to the sundae this spring. When scientists realized that ion-trapping dust was hiding 95% of the electric currents on Enceladus, nobody seemed to remember that's about the amount of the universe missing in the original models that required dark matter in the first place. If we are 5% at Saturn's moon, how much of the currents do you think we're detecting in the deep cosmos? And we're back once again. No dark energy needed, which would also eliminate dark matter. That is all in 15 months, folks. Wow. Two groups of scientists went looking for dark matter. They collaborated to look at the same thing, the cosmic web, which is supposed to be the macro-scale dark matter of the universe holding everything together, and on a smaller scale, the structure holding galaxies together and linking them to one another, often on a line, equidistant apart from one another. Astronomers have even constrained that distance to about 30 million light-years. On a line, equidistant apart is not gravity, but indicative of a wave frequency. But back to this. The headline is that half the matter is found, but what they don't say is what amount of dark matter was replaced. If they found this matter somewhere else, the question is moot, but they found it in the heart of where dark matter is supposed to rule over the entire universe. This direct replacement is not insignificant, and coupled with the missing electrons and electric currents they'll soon find across the cosmos, just like they found at Enceladus, a slippery slope has now birthed an avalanche. So, what did I just say? While the official article only claims they found some of the missing normal matter, the fact that they found it where dark matter was expected in the cosmic web is a huge blow. The web was supposed to be their stomping grounds, the core of its glue-like properties to galaxies and the universe. You can't exactly replace that. And so, since the missing baryons found were protons and neutrons, that leaves us with the electrons missing and the flow of said electrons, which, as you will recall, have attractive force on oxygen-rich rock and water, which looked a whole lot like the attraction of gravity. And we couldn't spot more than 5% of the electric currents here near home at Enceladus, and until that moment, they believed they saw all there was to see in the cosmos of the electric variety. This story is to be continued. Just know that while you may not hear much from the U.S. outlets, Nature has been ahead of the game too on this matter, publishing the last two great hopes for finding dark matter in China and the Xenon machine in Italy, having both failed. Applause for Nature in general for identifying that other ideas must prevail in the face of that evidence. Moving on to something that is already a battle of sorts, but was largely considered fringe science. Solar Effects on Cyclonic Activity, both tropical and extratropical, has been published over and over in Eastern countries, but only recently has begun to bleed over into the US, Europe, and Australia. We began tracking the solar and earthly storms connection in 2013. We've presented the positive results on this channel numerous times. The videos have inspired observers of all ages, and perhaps most notably, Ferris Wald, who just won the National Middle School Broadcom Masters Science Championship for demonstrating the connection between solar coronal holes and cyclone activity. This is not a claim where we stand alone either. The evidence of a modulation that is only beginning to be understood is convincing to many, on many levels, and on many stages. The next claim is the foundation of where we, and apparently NASA and ETH Zurich, are now. Over short-term and long periods of time, the peak solar magnetic activity in the IMF realm appears highly relevant to earthquakes, the ones that bypass Earth's magnetosphere and directly interact with Earth systems. It was NASA's Kongpapu Yen who realized that the charging and discharging action was likely, and that Earth's heliographic orbital position was aiding in the peak force applied. And it was Ohio State statistics professor Chris Holloman who found a way to take repeated observations of a pattern and prove it was mathematically and statistically real. Over 100,000 reads online, no existing descent. Then we come to the frustrating one. It's simple. We believe climate change is real. Humans have had and continue to have an effect on this system. Pollution is bad for a lot of reasons, not just climate change, and where temperature predictions have failed for about 20 years, with the exception of the strongest El Niño on record in 2016, we think that some of the hundreds of solar climate forcing papers being ignored in all modern climate models is likely one of the causes of that discrepancy. For that last bit, we have been branded as climate deniers. This, of course, was not done with any diligence or sense of reality, but in an attempt to control the impression one gets of the community as a whole. While that really didn't seem to me to be so blasphemous against mainstream science, we do know that solar forcing is about to get a big boost in the next round of models. 0.1% variation over the cycle will be seen for the scale variability it is, and threshold event forcing it deserves to be. But we have to wait for that officially. Perhaps we get that one wrong. As for the others, we are supposed to be the crazy ones on the internet according to some, but we never miss a day of work the sun doesn't miss. We've been right about our major points of community focus, where it takes a bit of the weird and unusual to find where the established mainstream rules allow you to venture into the unknown and either make an unforeseen breakthrough or see a bit further down the line and connect the dots in the outcomes of grand standard cosmological science experiments. You can count on this community and these updates to be there as long as we're breathing, and so goes for the free resources and other ways for you to get involved and help us continue this successful riding of the frontier wave. It's difficult to deny the forefront position of a number of these items, and when you combine that with the diligence and reliability to be there every day and deliver correct information that is merely not yet released in a headline, you'll know why there's more than 300,000 people in the community now, with over 25,000 actively involved in some way. This community is like any city with a frightening avenue or two, but if you're going to invite your friends, make sure they know about all the best things to see in town.